Welcome to the Art of Artificial Intelligence. In the previous video, we covered what artificial intelligence is and where it comes from. Now we can go deeper and answer the question, how does artificial intelligence work? So, let's get started. As you already know, AI is the ability of a machine to display human-like capabilities such as reasoning, learning, planning, and creativity. This power usually needs human intelligence for problem-solving or language comprehension. Computers do not have these abilities from the outset. They have to learn them, just like us. But we humans learn throughout our entire lives. Every single day, we learn by doing, from making mistakes, through someone else's teaching, and through constant repetition. A computer has neither the time nor the ability to learn the way we do. So how does a machine learn to act and react like a human lookalike? Imagine we want to teach an AI to continue the story of Max and Moritz by Wilhelm Busch. For those who don't know what this is all about, the story from an old German children's book tells of Max and Moritz and their 7 mischievous pranks. Instead of ending after 7 pranks, the AI should invent an 8th prank. So, to imitate the writing style and character of this story, a computer needs examples. Those examples are the 7 existing pranks. And with those, an AI has to be trained first, and training means a lot of math and calculations. So what do? We start with an untrained AI. You can picture it as an empty dictionary with pages but without any entries. To fill those empty pages, an untrained AI starts to analyze, in this case, the pranks of the German version Max and Moritz, and analyzing means counting. For example, all letters and words in the story. 1, 2, 3, 4, 5. In total, there are 10,080 letters and more than 2,000 words. And if we count them, we can easily find out the frequency of each one. That's why it's no surprise that the letter E is the most common letter, like in the German language. And the 3 most common words are und, der, and die. But the counting doesn't stop there. An AI also counts the letters in each word, as well as letters and words in each line, stanza, and prank, along with syllables or letters that often appear together, such as N or ing. This information already provides a benchmark for a pre-framework of our new 8th prank of Max and Moritz. By knowing different frequencies, we can easily calculate, for instance, the average number of words per prank, per section, and per line. That's why a line in our new prank is going to have around 5 to 6 words, for example. However, our untrained AI also looks for word groups that often appear together in the same sequence order, such as Max und Moritz, or punctuation marks and spaces. We summarize and name all these letters, syllables, words, word groups, punctuation marks, and so on as structures. These structures can be ranked and sorted, for example, by how often the structure appears, its position in a line, a stanza, or the story, or by the length of the structure itself. Structures that are similar or appear repeatedly are grouped together as so-called clusters. Clusters are collections of similar structures that share the same property, such as the same line end position, starting with an uppercase letter, having the same length, or another characteristic. The AI does this over and over again with every piece of structure you can ever imagine and will link, sort, group, and cluster them. The more text, the more clusters and links will be created, and the more information will emerge. Especially if the AI gets text from different genres and can train on them. As a result, an AI evolves clusters of structures like words that occur repeatedly in short stories, poetry, tales, newspapers, or academic articles. Furthermore, the AI also evolves clusters of what we know as verbs, nouns, and adjectives, without even knowing their meaning, but only of their position and the location of the other letters, syllables, and words in their environment. By clustering structures, an AI is able to capture the style of a story, in this case imitating rhymes. But what are rhymes for a normal computer? A typical computer can measure how many letters at the end of 2 lines are the same, but a human must tell the computer before. Which 2 lines should be checked? Which words in those lines are relevant? and how many end letters need to agree to be a rhyme. A computer can then compare those lines according to the given rules, without flexibility for new situations and rhymes with fewer letters. An AI is different. It recognizes a rhyme as a pattern on its own. This works by clustering structures with the same attribute, such as line-ending words, words with the same end letters, words with a similar sounding ending using phonetic symbols, and line positions. It measures how often these clusters appear in the same way. To be more precise, an AI calculates probabilities of how often something occurs in the same context. When the letters often match at the same place at the end of two lines, one above the other, the AI calculates the probability of how often such clusters appear and detects this repetition as a pattern, which we call a rhyme. A pattern is a collection of rules that describe how the text is built. In this case, the pattern is a rhyme connecting the last words of two lines by sharing the same end letters and knowing how to shape each line in the story. The rules are statistical probabilities that an AI derives from this pattern. That's how an AI learns, and if humans ask an AI for a rhyme, it will recall all these implicit patterns. The story of Max and Moritz has many patterns, such like each line starts with an uppercase letter. One stanza has at least 2 lines. One stanza has an even number of verses, and much more. This is one of the significant features of AI, the ability to recognize patterns autonomously and apply them in new situations. For example, to read and understand text, or generate new text by using trained patterns. For an AI, those patterns and rules are only numbers and won't be written down as a list. They will be incorporated into the core of an AI, which is a model. That's why we also call a trained AI a trained model. The process of learning, also called training, is driven by a so-called algorithm that performs massive calculations and clustering, and this is what we call machine learning. In our example, the 7 existing pranks represent the training data. In reality, training data for artificial intelligence is a collection of more than 300 billion words. By the way, the entire English Harry Potter series with 7 books has just about 1 million words. Now let's ask ChatGPT to develop an 8th prank for Max and Moritz. The texts are calculated in real time, meaning that for each new word, the probability is recalculated based on the context, considering the previously generated words. If the text says Max and, the AI calculates the probability for each possible next word and chooses Moritz with the highest probability. And here is the 8th prank. Well, the result is a pair rhyme and has the typical patterns that we had before, but unfortunately it's disenchanting because it lacks a sense of humor. And that's the difference between an artificial intelligence and human intelligence. Humans have feelings, emotions, and social intelligence, which makes us incomparable and unique. That's why your hard-learned creations and capabilities are irreplaceable, even by an AI. Now let's shortly summarize how an AI works. Implementing artificial intelligence always starts with a training known as the process of learning. This requires a large amount of training data, such as text examples, as the learning material. An untrained AI has an algorithm that starts to analyze the text by counting letters, words, syllables, and other structures. Similar structures that occur repeatedly will be grouped together into so-called clusters. Many clusters can indicate a pattern, a specific structure that appears often in the learning material, such as a rhyme or uppercase letters. An AI will derive rules from those patterns and mount them into the core of an AI, the model. The model can be compared to a brain and will be formed by the training process to a trained model or a trained AI. An AI needs to work within a system or application with a user interface, allowing users to type in their prompts and inputs. The AI will read your texts based on its training and can generate answers by calculating probabilities. This feature is both exciting and sobering at the same time. Imitating flexible human intelligence by writing texts like a human, but lacking with social intelligence that makes a human being. Try your luck and ask ChatGPT about the 8th prank of Max and Moritz.